Hello, welcome to our video lecture on topographic maps. If you will, the first page you're going to need is your vocab page. It looks like this. So if you'll turn to your vocab page and your bell ringer page, we'll get started. Here's your vocabulary for the day. We've got density, equator, prime meridian, and latitude. If you will, pause the video so that you are able to record your vocab. When you're ready, unpause me. Alright, we are not doing a vocab quiz today. Instead, we're moving on to our bell ringer. So I would like you to predict to me which is the highest point on the map and which is the lowest. So pause the video, write this in your bell ringer spot. You can write highest and then the letter, lowest, and then the letter. So for the answer for your bell ringer, the highest point is actually point number C. The lowest point is actually point number A. So we're going to learn about topographic maps. It's the way to see in a 2D version 3D features such as valleys, mountains, depressions, lakes, rivers, and streams. So we're going to learn a little bit about them, learn how to read them, learn how to see what they tell us. So if you will, we're going to turn in our notes to the page that looks like this. This is your page today. It's not a doodle note, it's just a regular guided note. We'll get started. So this is the Bryson Canyon in Utah National Park. So it gives us a nice little map, and you can see that it is actually different levels, right? So these are different elevation heights. If you were standing down here at the bottom, it wouldn't be the same as if you weren't at the same elevation as if you were standing right here. So topographic maps represent the Earth's surface features and elevations of the Earth in a two-dimensional format. Examples of these features are hills, rivers, valleys, mountains, all that good stuff. It can show lakes, it can show oceans if we're in the right area. Just like when we talked about our latitude and longitude yesterday, the globe is a 3D representation. The map is 2D, right? So these topographic maps are actually a two-dimensional format. The lines we're going to learn in a second are called contour lines, and they represent different elevations. So again, if you need more time, always pause me. If not, we're going to keep strolling ahead. So contour lines, these are lines that connect points at the same elevation. Our lines never cross. They might get real close together if we have a steep area, but they will never cross. If our contour lines are distant or further apart, that means our landscape is a gentle slope. If our contour lines are very close together, that indicates a steeper landscape or a very large drop-off. A V indicates a valley, so if your lines come to a V, it indicates a valley. V's and U lines always point upstream. So rivers flow from what elevation to what elevation? What does gravity say? Gravity says that our rivers will flow from high elevation to low elevation. And a closed circle indicates a hill or a mountain. So you're going to fill in the blanks. I would like you to write underneath where there's no blank and no bullet point, closed circles indicate hill or mountain. Alright, so those are contour lines explained. We're going to see a map in a little bit. If you can see down there, past my face, will move me. This is an example of a contour line. So you have this one that's at 700 feet of elevation, and then you have this one that's labeled at 800. These ones in between are also contour lines, but we don't label every line. You could figure out the contour interval or the elevation distance between one line or another using a little bit of math, and we will in just a second. But that is in a second. So here's a picture, right? So this connected circle does indicate mountains, so I can see at least 1, 2, 3 mountains. The V's indicate valleys, right? So this is a valley, this is a valley, this is a valley, and they always point, what did we say? Always point upstream or to higher elevation, right? You see how these V's are pointed towards the mountain? That's because they are uphill, right? So the water comes down from the mountain, trickles down, goes down in elevation, and will drain somewhere. Sometimes the ocean, sometimes a bigger body of water like a lake or a larger river. Just depends on the landscape. This is what we call a depression. They're lines that show a decrease in elevation, and these are lines that are dashed. So, for example, this would basically be a hole in the ground, right? So you've gone below sea level and now you're going lower and lower. It could be a cave, a cavern, an opening, a ridge, whatnot. This is indicated in your map by a dashed line. So can you see the depression in our map here? If you didn't locate it, the depression is right here by the number 5. See? Indicated by dashed lines, so these are actually going down in elevation. It is a hole in the ground. Here's our example picture. So these are depressions right here with dashed lines. They're going down in elevation. This is an example of a mountain, another mountain peak. Our contour intervals, that is the difference between one contour line and the next. So like I said, with a little bit of math, we can figure this out. And the contour interval is consistent throughout the whole map. So if one interval represents, if this space represents 10 foot of difference between one line to the next, it is going to be the same throughout the map. For example, our contour interval here is 50 feet. That's what it says, CI, contour interval, 50 foot. So the difference between this elevation and this elevation is 50 feet. Now this map doesn't tell us where we start at, but normally some of these lines will be labeled with their feet of what they represent. But all that we know is that this point right here is 50 foot higher than this point. This point right here is 100 foot higher than this point. This foot right here is 150 feet higher than this point right here. Same thing. This foot right here is 50 foot lower than this foot. This foot right here is 50 foot lower than this foot. Getting the idea? Our contour index, every 5th contour line is bolded and labeled with the elevation number. The difference between the two contour index lines divided by 5 is our contour interval. So, for example, let's find a line. Here is 350 foot. This line right here represents an elevation of 350 foot. If you follow this line, I want to know the difference. If I follow this line, I'm still not seeing a label, still not seeing a label, still not seeing a label, still not seeing a label. Keep going. Still not seeing a label. That 390 is not it. Haven't seen it, haven't seen it, haven't seen it. Bam, 400. So the difference between this line and this line is what? 400 minus 350 is what? 50. So there's 50 foot of difference between this line and this line, but I want to know the difference between this line and this line. So what I would do is I know that this is 50 foot difference. I would count the lines. 1, 2, 3, 4, 5. So there are 5 lines or 5 steps in between each of these 5 elevation jumps in our map. So I know this is 50 foot, and my math said over here that I need to divide the difference between the two contour indexes, which we said was 50 divided by 5 equals my contour interval. So 50 divided by 5 is 10. So each of these jumps equals an increased elevation of 10 foot. So this would be 360. This would be 370. This would be 380. This would be 390. And we know that this is 400. See how that works? And lastly, the difference between the highest and lowest point on the graph is going to be called a relief. Okay? For example, if this is my highest point right here, and let's just say that this is my lowest point at 350, which it's not, but let's just say it is, it's right here, 350. So this is 400. We know it goes up by 50 each time I get to a bolded line, so this is 450. And we know one more not bold line is 10 foot. So 450 plus 10 is 460. So this is 460 foot tall. And let's just say this is my lowest point right here at 350. So 460 minus 350 foot equals 110. That would be our relief, 110 foot. So these are pretty simple. There's some reasons why you might want these. If you were a hiker, for example, you would want to know the height of a mountain before you climbed up it. You would want to know anything you're going to come up against, right? I could give you a simple map from, let's just say I gave you a map that looks like so this is your map. Say you are supposed to walk from point X to the circle. You might think it's really easy, right? I'm just going from the X to the circle. But if there's a mountain right here, it's going to be pretty difficult, right? So you might want to use this topographic map to show you the features of the land before you go hiking, before you move. In a survival situation, you would want to know, would it be easier to go up a mountain or around the mountain? So things like that. You would also know features of the land, right? Valleys, where you might find more lush and green land where you could eat, or a mountain where it might be less predators but less food up there. So those would show you some just examples of the terrain, right? There are a couple questions for you at the bottom of your notes. If you would please complete those, that would be great. These are some true false. That's vocab for another day. All right, so you're going to complete the questions about Baker Hill, please. Going the wrong way. About Baker Hill, please and thank you. You're going to take a screenshot of this picture of your notes. It could be something simple like this, like you screenshot the screen. Just make sure I can see all of it, and then you write neatly so I can see how you're doing, especially this bottom part where I need to check over. The Baker Hill actually gives you a really good example of the 3D structure versus the 2D, right? So this might be what you see if you're standing at the bottom of the mountain, but this might be what you see on the map, right? So it shows you my peaks, it shows you the valley, all that good stuff. So thanks for watching this video, guys. Do not forget to submit a picture of your notes. These ones don't need color unless you want them. Submit your pictures to your assignments to get credit. Have a great day, guys.